Okay, let's continue this crash course with Appendix B, which is about sequences and series. And typically in Math 208, we expect to get a question on the midterm on sequences and series, and it'll occasionally show up on the final, but this is more so a midterm situation. So what we're looking at here, okay, let's first talk about what a sequence is. A sequence is just a string of numbers in a row. Okay, but you have two types of sequences. You have arithmetic sequences, which we'll start with, and we have geometric sequences, which we'll see in a second. So an arithmetic sequence is a sequence where the gap in between the numbers is constant. Okay, so the jump is either an addition or a subtraction, like here, for example, plus 4, plus 4, plus 4, plus 4, plus 4. You see, this is linear. It could also be negative, or it could have been minus 4, minus 4, minus 4, but the point is that it has a slope, okay? So the first thing you have to be able to solve for is the nth term. What I mean by nth term is like the 17th term, the 33rd term, the second term, right? Like a specific term in the sequence. And here's the formula that you want to use. The nth term is the first term of the sequence, A1, that little 1 is the first term of the sequence, n minus 1, and then d, that's the slope. Okay, so take a look at this question. Using the sequence above, so the sequence up here, what is the 35th term? Well, let's follow the formula. If I'm looking for the 35th term, the first term was 2. Okay, so A1 is 2 plus n. N is the position. I'm looking for the 35th term. N is 35. That's your n. So I'm going to put 35 minus 1 times the slope. What was the slope here, guys? The slope, I mean, it's clear, right? But the slope is basically just A2 minus A1. 6 minus 2 is 4. That's the slope. It's increasing by 4. So times 4. So 2 plus 34 times 4 is 138. The 35th term is 138. Okay, let's try another one. If the first term in an arithmetic sequence is equal to 5, and the 11th term is equal to 35, compute the value of the 48th term in the sequence. Okay, let's go through that again. So the first term, A1, is 5. The 11th term, A11, is 35. I want the value of the 48th term. So here's where it can start becoming a little bit more complicated, but it doesn't need to be. In a question like this, what you want to do first is figure out your slope. And how you're going to figure out the slope is by using that same formula above, but working backwards to the slope equation, to the slope variable. So in that case, what you want to do is start with the one that you have, right? So start with this one. So n is A11, right? Because we have it, so 35. We also know the first term is 5, so 5. N, since you put A11 as your AN, then your N is 11. 11 minus 1, and then you're able to solve for the slope. Okay, guys, so if they don't give you two consecutive values, it's totally fine. Use the same formula to solve for the slope, and then from there you can kind of figure everything out. So this would be 5 plus 10d, 30, right? If I bring that 5 over, that's 30 equals 10d divided by 10. So the slope is 3. Great. Now that you've got your slope, it becomes a regular question just like the one we saw before. So if I'm trying to find A48, I'm going to use my A1, which is 5. 48 minus 1 times 3. Okay, great. So that's how you find a specific term. The next thing you have to understand how to find is the sum. So if I want to find the sum of n terms, so the sum of the first 10 terms, the sum of the first 20 terms, and so on. So pretty straightforward. Formula is n. N is the same n as before. That's just the number of terms over 2. First term, last term. First term, last term. Okay, let's try that out. Okay, so here we have And this is typically what it'll look like on an exam. They'll give you an equation. So how do I know that this is an arithmetic function and not, or an arithmetic sequence and not a geometric one? Well, they've given you a linear equation, okay? So the trick is this. If the x is not in the exponent, just to give you an idea of what I mean, okay? A geometric sequence looks like this, where the x is in the exponent. But if they give you the x down here, where it's basically just a linear equation like we saw in that first chapter, this is an arithmetic sequence. And the coefficient there, the slope, is your slope. It's the same slope as this is basically d, okay? So, and then here, this is really important, okay? They're asking you to find the sum. It looks like it's 49 terms, but it's actually 50 terms. Why? Because the 0 counts. They're essentially saying this. This number down here is the x that you would plug in to find the first term. So your A1 is 4. Okay, I'm following the equation. Okay, you take this number and you plug it in. 4 times 0 plus 7. Okay, so my A1 is 7. And your AN, you plug in the number at the top. Okay, so AN is actually A40, well, AN, I'll just call it that. 4 times 49 plus 7. Really important. The most common mistake here is students thinking that there's 49 values, but there's actually 50 values, because if you count the 0, there's 50. Okay, so my N is actually 50. This is the 50th term, because this was the first term. Okay, then you follow the formula. So if I want the sum of 50 terms, it's 50 over 2. The first term is 7, and the last term is 203. 25 times 210 is 5,040. Okay, so I'm going to repeat that. The number at the bottom, okay, is the value you plug in for your first term. The number at the top is the value you plug in for your last term. And to know how many terms there are, now this one's easy because I can just tell you, oh, if it's a 0, add 1. But the idea is if you take the number at the top minus the number at the bottom plus 1, that'll always give you the correct n, even when it's not 0. Like, look at this one. This one's a little bit trickier because you're like, oh, is it 98? It's not 98. Number at the top minus number at the bottom plus 1. There's actually 99 terms here. Okay, pause the video, guys, and try this one on your own, okay? I'm going to get right into it, but I want you to try it. So there are 99 terms. Now, my first term I'm going to find by plugging in the 2. So my A1 is minus 2 times 2 minus 10. So that's negative 14. And then my 99th term, because there's 99 terms, right? My AN, or A99, whatever you want to call it, you plug in 100. You plug in, so minus 2 times 100, that's negative 200, minus 10 is negative 210. And then you follow the formula. If you want to find the sum of those 99 terms, it's 99, that's your n, over 2. Okay, I'm following this formula here. First term plus last term. Careful with your negatives here, make sure you respect them. And that's it. So 99 over 2 times negative 14 plus minus is just a minus, so minus 210, 11,000, or negative 11,088. Okay, so again, your n, you find it, number at the top, number at the bottom, so number at the top minus number at the bottom plus 1. Now we can look at the geometric sequences, and the first thing I want to bring your attention to is the rate of change. Look, here it's plus 2. But then it's plus 4, but then it's plus 8, but then it's plus 32, or 16, because it's not a plus at all. Here, the rate of change is a multiplication. It's a rate of change. It's not a slope anymore. So this actually times 2, times 2, times 2, times 2. It is a constant rate, but it's a multiplication. So that's the big difference. Okay, so the first thing, finding the nth term. How do you find a specific term? Well, you follow this formula. Okay, so The formula is pretty straightforward. It has the same components as the previous one, except for R. R is your rate of change. We don't use D. D was for the slope. R is for the rate. Okay, so if you look at the sequence above, the rate here is clearly 2. Okay, but if it was less obvious, like if you're looking at this and saying, well, how do I know it's times 2? To find your rate, take A2 minus A1 over A1. It's a percentage change. You can do it that. You can think of it as kind of a percentage change, a new minus old over old. But that is how you would do it. Now, they can make it more complicated and give you 2 non-consecutive numbers. We'll deal with that in a second. Okay, but let's just start with that. So here our rate is 2. You can see it. If I did like 4 minus 2 over 2, that's 2. Okay. So if I want to find the 11th term, I'll take the first term, which was 2, times the rate, which is also 2. And in the exponent, I would put 11 minus 1. So 2 times 2 to the power 10 is 2048. Okay, let's try this one. If the first term in the geometric sequence is 4, so A1 is 4, and the third term is 2.25, what is the 7th term? Well, we can do it the same way that we did in the previous situation, where if they give you 2 non-consecutive, just use one of them. Like use the A3 to solve for the slope. So I'm going to use my same formula up here, but my A3, I have it, is 2.25. A1 is 4. The rate is what I'm looking for, and N is 3, because I put my A3, so 3 minus 1. And we solve for this. Now to solve for this, you want to start by, let's clean it up. So let's divide this by 4. This will get rid of this. So right now what you have is 2.25 divided by 4 equals R squared. And then you want to get rid of that square, so you can square root, you can cube root, you can do this. You can take that whole thing, whatever the exponent is, put it to the power of 1 over that. Or, right, if you prefer the roots, it's a square root. But it could be a cube root, it could be a 4th root, it could be a 5th root, whatever, right? So if you do it on that side, you also have to do it on this side. So your rate is the square root, so let's punch this in, of 2.25 over 4. So it's 0.75. That is your rate of change. And now we can use that same formula to find A7. So A7 is A1, which is 4, times your rate of change, 0.75, 7 minus 1. Okay, that 7 is that 7. 4 times 0.75 to the power 6 is we'll call it 0.71. That's your answer. All right. The sum. So another formula for you guys here. Let's jump right into it. It means the same thing, by the way. It means the same thing. It's just the sum of the first however many terms. Now, there's a special situation where they might ask you for the sum of all terms, like the infinite sum. You would use this formula for that. But let's start with one that's like this. So what do I see here? I see the same thing as before. I see that I have 9 and 0. So I know that my n is, if I take the number at the top minus the number at the bottom plus 1, I have 10 terms. My first term, I'm going to plug in the 0 into x. So your A1 is 7 times 0.5 to the 0, which is 7. So now if I want to find my n terms, oh, and remember that when you're looking at an equation like this, if the x is in the exponent, that's how you know that it's a geometric sequence and you're supposed to use this formula. So 7 is my A1. The rate we said is, okay, so the rate is the base of the exponent when you look at an equation. So 0.5. N is 10. We established that before, minus 1. And then over 0.5 minus 1. Okay, let's punch this in. 7 times 0.5 to the power of 10 minus 1 divided by. So I get about 13.99. Okay. Now, what if there was an infinity sign at the top? I want the sum of all the values starting at a1, which I'm going to find by plugging in the 0, until infinity. So let's start with a1. Okay. Well, if I plug in, and I think it's the same equation as the one above, right? So again, if I plug in my x there, I'll get 7. But then you need to follow this formula. It's really simple. You take your a1, your 7, and you divide it by 1 minus your rate. And the rate, remember, is the base of the exponent. So you get 14. Okay, let's do one more. Okay, again, you guys do it on your own. Pause the video and try it. So what we have here, 10 minus 1. So 10 minus 1 plus 1, we have 10 terms. So n is 10. The first term, a1, plug 1, whatever number you have at the bottom, into the function. So 4 times 1.5 to the 1. So that's 6. The rate is the base of the exponent. That's 1.5. And then you have everything you need. If you want the sum here of the 10 terms, take your first term, which is 6, the rate, which is 1.5, your n is 10 minus 1 over 1.5 minus 1. $679.98. $679.98. Okay, great. So that is how you find the sums of arithmetic sequences, geometric sequences. That's how you find the nth terms. Like I said, very common on the midterm. If you have any questions, guys, please don't be shy to hit me up on Discord. See you at the next video.